So again, prototype is basically like saying, it's the way that inheritance works in JavaScript, right? So we can log pretty much any kind of object, right? So you guys know objects, right?
Yeah.
Cool. So basically, like, the prototype property of an object is where we can put methods and properties that we want other objects to inherit, right? So the constructor for prototype property is actually not the prototype of the constructor itself. So that's really fancy stuff. All that means is that when you have an object in JavaScript, okay, and you create another object from it, you have methods that you could use, like an array, right? Let's say 1, 2, 3. You can see that, right? You guys can see this here?
Yep.
Perfect. So this is just a little recap. We did this last time. So this is basically an object, okay? An array is an object, okay? The array has a constructor. The constructor is the actual array. So when you know how you can call like for example, let's save this under a variable, right?
Yeah.
Right? So when you call A, you're going to get the array, right? So what is instance of A? Or A, what's the syntax for this? A instance of, okay, maybe. Anyways, so the point here is, you okay? Instance of, I forgot the syntax for it, but anyways, so if you do like A is equal to 1, 2, 3, right? What you're actually doing is you're kind of creating a new array, and that array, you know how you can call like a dot length on it, right? Or you can call like a dot, you can do a dot push, and then we'll do like a 4 there, right? Right? So when you log A, you get 1, 2, 3, 4, right? So that's cool. Like, we're all familiar with that, right? So how does this stuff actually work? Like, you know, that's a big question. So let's just say, that's kind of like how the function constructor works, okay? Now, what exactly does that mean? This is a built-in object, right? Arrays, like, you know, hashes, pretty much anything in JavaScript function is also a built-in object, right? So what we're doing here is, you know how you could do like an object like for example, let's do like a person, right? So this is object literal. You guys know object literals? No? Yes? Yes? Say John, right? And let's say what's his date of birth? Year of birth. When should John be born? Tell me, guys. 1990, is that good? No? Yes?
Yeah.
All right. Cool. So, and let's just say John, I don't know, John is a teacher, right? Cool. So we could do, so you guys agree this is a plain old simple object, right?
Yeah, it's an object.
Right? So, and then this is called this is an object literal, okay? Which is just a declarative way of creating an object. We all know this. This is like just a little throwback, right? So what is a constructor? So a constructor, you guys have seen this. Let's use some ES5 here. So John is a person, right? We all agree he's a person. He could be a robot, but not yet. It's not 2030 yet or something. So let's just say he is a person, and you know how this works, right? The function constructor. So what can you tell me? What's the difference here between going like this? Var person is equal to function. What's the difference in these two? Anyone?
Between the object and what is now?
Between these two, line 7 and line 11.
One is a constructor.
Mm-hmm.
The capital B.
Mm-hmm. Okay, cool. Perfect, perfect. So let's say we want to create John, right? But so the best way to think of it, and I think we talked a little bit about this, is I think of, like, imagine you had a classroom. There's a whole bunch of us, right? Imagine there was 30 students. It would be crazy to put their name and date of birth and all that stuff every single time, right? It's a little bit crazy. Like, think about a program that you would run. So you'd probably do something like this, like a constructor, and it accepts a name, right? It accepts a year of birth, right? And the person has to have a job. Kind of like matches our thing, right? So what would I do here? How would I make this person? There's only 2 people with a mic. How about Derek? Tell me how I would do this, Derek.
I'm multitasking while I watch you, so I'm not. I missed what you said. Sorry.
No worries. So like you see here what we got here, Derek? We're trying to create a person object. So like if I'm doing a constructor, like how would I make this object using a constructor? We got to start it for you.
You put name, periods, and then name.
Close, close. Okay, so let's help Derek out, and we're all doing this together. And by the way, guys, like I'm just gonna ask you guys randomly along the way, and it's not to like call you out or nothing. I just want so we can all kind of participate, learn from each other. Like I don't know everything, and you know I can learn from you, you can learn from me, and then it's symbiotic. Okay, so don't feel bad at all. Like a lot of the times when I'm at work, if I don't know something, I tell my like lead dev or my CTO, I tell them like, look, I really don't know. Why don't you share your knowledge with me? And then I'll take that away and come back and let you know how far I get. Okay?
Do you one question, Dennis? Do you think the new way, like the I6 way of doing the constructors is easier, like declaring the class?
I would say the thing that the ES6 class syntax, which you're going to run into in React, is quote unquote easier. It's easier to read, but unless you know how it actually works under the hood, you will run into problems very, very quickly. Because the issue with it is when you add syntactical sugar, this is what I was mentioning earlier. So ES6 basically took all these things that we're going to do today and put a layer of abstraction on top of it. So like you don't want to put like, I'll show you 2 different ways of creating an object, and this will lead to why classes were even created. Now classes are used in other programming languages. Martin knows, but you guys don't know. I do Ruby development, JavaScript development, I do Java, I do C#. So JavaScript is the only one who just recently put classes in. It sounds crazy, but that's the way it is, right? So when you're in JavaScript, up until not very long ago, this is basically how you had to do it. Now, understanding how it works again is really critical, because if you take it for face value, ES6 will basically betray you in more places than not. It is wonderful, don't get me wrong, but you kind of have to understand what's happening so that you can debug it better. Okay, does that make sense, guys?
Yeah.
Cool. All right, cool. So, who's?
I have to use this.
That's right. That's right. Who said that? Who said that? Angelina? Ah, okay, perfect. So we're gonna say name, right? So we're gonna say this dot name,
Yeah.
and then is equal to right? And we're gonna say what, name, right? And then we're gonna say this dot year of birth is equal to year of birth. And gets cumbersome really fast, but this is the joy of JavaScript. And that's equal to your job. Okay, cool. So now I can just go, how do I get this person here? Let's just say John, right? I think it was John, right? Okay, cool. So this is actually what this was leading to. You guys see this right here?
Yeah.
Okay, what do you think this actually means? Let me, before you answer that question, think about that, okay? Just think about this, okay? And you can see, and we'll talk a little bit more about it because that particular keyword is extremely critical.
Does it create like a new instance?
Yeah, we talked about it a little bit before, so you have a head start, Martin, but I'll give you an A for memory. How about that? Okay, cool. Cool, and let's do a little log here. John, actually, let's see, does table work on this? Cool. You guys ever do this, by the way?
First time ever.
See how it comes out there?
Yeah, we never did it. Oh, I don't think we did it.
Yeah, keep that in your back pocket, guys. You would be surprised how amazing console is. Everybody always console.log. It's great, but it's much more powerful than it first appears, okay? Anyways, so moving on, okay? So why was I harping on it? Let's just destructure this. Okay, so we have an expression. Actually, it's a declaration, sorry, but okay, so the new operation, okay? What the new operation does, guys, and this is super, super critical, okay? So what we're doing here is we're saying, give me a new person and pass this in. We pass this in, and then the keyword this, right, points to the object, right? And then we basically get name is John, year of birth, so on and so forth, right? I mean, this is all the stuff that we understand, right? What the keyword new does, it does two very fundamental and very important things here, okay? And this is what you need to understand whenever you're using, like let's say you want to scope certain functionality to an object. You must use the new keyword, okay? Now, why is that? Because what happens is when you say new, what it actually does, it goes into the prototype chain, okay? And it actually creates an object. You see this prototype? Right? So we have the person. We know the person's John. He's a teacher, and he's born 1990, which is a little bit ridiculous, but whatever. We'll accept it. And then it also has a prototype. Right? But where did that prototype come from? That is actually all objects are an object over an object, which I know it sounds really weird, but essentially the new keyword instantiates a blank canvas. It's an empty object that comes with the most root object, and it comes here. So this is the constructor for this person, and this person also has a prototype, and that prototype is all of a sudden the object with all sorts of different stuff. So is prototype of, has own property. What else do we got here? Value of toString. You guys used this before, right? That's where this stuff comes from, okay? So why is that relevant? Well, the reason why is when you create a blank object and then tell it, hey, blank object, I want you to scope to person, what it actually does is it sets the keyword this to point at this particular object. Without the new, the keyword here, this dot name would not work. Okay? Again, the keyword new does two fundamental things here. Creates a new object for you to populate as you please, and it scopes the keyword this. Okay? Why is this also important? Because in ES6, you guys are using arrow functions, right? You've seen Uzair using arrow functions, right?
Yeah.
Okay, arrow functions change this behavior. Okay? That is one of the things, that's why I said, ES6 changes how things work under the hood. Without understanding how it works normally, it is really hard to understand why certain things do not line up or why there's a bug or whatever. Okay? Cool?
Just to reiterate, you're saying that this functionality becomes available in the object with the new, if the new word is triggered.
Yes, so let's rephrase that. I understand what you're saying, but let's rephrase it in a way that is a little bit less convoluted. I would say to you, think of it that the new keyword scopes this keyword to the object being constructed. Okay?
And that's a way of linking the parameters to that object, right?
In this particular case, yes.
Okay.
But the whole point is so that when you use the keyword this, it actually knows what to reference. Otherwise, if I just type this, it gives me the window, right?
Yeah.
And why is that? If you do the keyword this in node, for example, what does it give you? It gives you the actual node, right? And the reason why is because it hasn't been scoped to anything. So you're not telling JavaScript that, hey, when I say this, I want you to talk about the person, whether that's John, Mary, Amy, Stephen, I don't care who it is, right? Cool. So let's do something else here. So what's the next thing that we usually do? We go this dot, let's do a little function, right? Calculate age or something? I don't know. Let's find out how old he is, right? Is equal to a function, right? And in this function, we're going to take, what is 2018, I hope. And we're going to say this, right? You see how it starts to work in this fashion? This dot year of birth. Okay? And then we can say John dot calculate age, and then we'll invoke it, right? Let's give it a log here. What did I mess up? What did I mess up here? Oh, yeah. Calculate age is a function. John.calculate age. Missing argument. Yep. Cool. So we got the log here, right? And then, cool. Interesting. Okay. Anyways, the whole point here is we're going to use a prototype. You can see how this is buggy, right? Mm-hmm. So I just got a little bit of the syntax wrong, but it's not a big deal. So what we're going to do now is, you see, here's the thing. Let's suppose that we have more than one person. Let's just say we go like this. And let's say we make, I don't know, Mary, right? And let's say we make a Mark. I don't know. Let's say this person is, I don't know, really old, 69. I don't know. Is that old? Let's make this person even older. 48, 1948. And let's say this person is a designer, and this person is, I don't know, retired, right? 1948, they're retired, right? I'm not crazy, right?
They should be.
They should be. Okay, I'm not crazy. Okay. Actually, about, yeah, that makes sense. This dot. Just want to see something here. And then it's 2018 minus, let's return that. It's actually log. Let's actually log 2018 minus this dot year of birth. Cool, so we're getting it. You see this?
Yeah.
Even though that kind of doesn't make sense.
Because all the variables are named John.
Correct, yes. Thank you. Someone's paying attention. Okay, so let's call this Mary. Let's call this Mark. Cool. Okay, so that makes more sense. John is 28, right?
That should be right.
Yeah, that makes sense. 1990, 2018, he's 28, right? Cool.
Yeah.
Cool. So we're still, here's the funny part. We're still on super basic stuff, so I'm gonna just ramp it up a little bit, but just bear with me, okay? By the way, anytime, same with Celia, Derek, Nareen, just go off mute and stop me at any time if you have a question. I'd rather you ask a question than not, okay? And I don't mind going on a tangent or whatever, just ask Celia and Martin. Okay, cool. So
Is slacking. I'm not sending out the.
I will. Actually, that reminds me, I need to Slack the last session too, so thank you. That's actually a good point. Okay, so let's do Mary. Let's do Mark. Right? So we have these people. Actually, no, that's too much. Let's do this here. Mary, Mark. Right? So this works, right? So let's do a little something here. Let's do a log here. Okay, cool. So what does this mean? Every time we make an object, we create this copy. Do you guys agree?
That's right.
Every time we make a new object, so for Mary and John and Mark, every single time we make a new function, right? You can see it lives here, right? Right, you see? And this is actually interesting because you see within the function, you can see it has its own prototype, and the prototype of the function is a function, and the prototype of the function is the object. You see that? See here? And you see here? This is why we say everything in JavaScript is an object. Okay? This is proof. So you can, the further down the rabbit hole you go, you will see that they all are sources of the same thing. And when you actually call a function like this, what you're really saying is new function like that. Okay, guys?
Gotcha.
Dennis,
Yeah.
in this context,
Mm-hmm.
if we take out, if we delete from line 1 to 5, still get the same.
Of course.
Okay, so line 1 to 5 is not necessarily when we create.
No, that was to give you That was to show you that you can do the same thing, but what we're doing here is we're making a blueprint.
Right. No, it makes sense. I just wanted to be sure that.
Yeah, no problem. It's a good question. It's a good question. So let's take this one step further. What were we talking about the whole time? We were talking about prototypes, right? And one of the things that matters most is, like, think about it. Does it make sense that every time that you decide you're going to create an object, you're going to package this function? Like let me ask you this. When you create an array, right? Do you also say, like, I don't know, add length to it? When you create a new array, like a is equal to 1, 2, 3, right? We can immediately do a dot length, right? What the heck? I'm not in. It keeps trying to think I'm doing like React or something, you know? Okay, so you can see here, you can immediately do it. It's not a problem, right? Let's just do log LG and then a dot length. I don't know. Let's do that, right? So you know this works, right? But it's not like you went there and said, because we know that an array is an object, right? And we know this person is an object. But this time we had to specify calculate age before we could call it. Same way we called it dot something, right? Same way we did. It was no different than dot length. Like this a dot length is no different, right? So the question is why, right? And like, if you think about it logically, imagine that this function was like this many lines, right? Let's just imagine that there's many lines. Would you want to bring that on every single object? You know, and imagine now, this is, because this one's really simple, it's just one line, right? But imagine it was like 300 lines. There's no point to do that. So this is where inheritance comes into play. So what we're going to do, I'm going to make a little space here. What we essentially do is we utilize the constructor, the prototype methods, okay? Have you guys seen anything like this?
Yeah.
So I'm going to add it to the prototype. But the key thing here is we're adding it to the person prototype. You see that?
Yeah.
Okay. So I'm going to do something like, it's going to do exactly the same thing. I'm going to cut it out here, right? I'm going to say, forget this noise, right? And you know what? While we're at it, let's just say that, I don't know, what do you guys want to add to this person? You want to give them like a mood? Let's give them a mood. Let's say these people, every person that we're going to construct, they have a mood, right? And the mood is going to be, I don't know, let's say the mood is happy. Okay, so there's two different things here. We're setting here a property. So this is a property, and this is prototype method. Okay? Now, based on what we discussed, what do you guys think will happen when I reload, when I go to inspect this? And just so you know, remember I hit reload, look, it works. Did you see that?
Yep.
So, why? If I look here, where is the method? The method is nowhere, right?
Mm-hmm.
But the method is in the prototype. And the prototype is the person, is the prototype for the person itself. Because here, if we open the prototype, you still see you can go one level deeper. And you see how it says the constructor, right?
Mm-hmm.
So this is actually pointing to this. It's saying, here's your properties, but inside, this is actually what's being built. So let's say you had like also like a bunch of other, I don't know, let's say A, B, C, even though I did it out of order, right? And then you declared them here, but you never filled it in. These will be null, right? Like, you know, if JavaScript doesn't care how many variables you pass in, anything that's not passed in turns into null, right? So it would actually be listed here. So whenever you're looking at some kind of object and you want to find out what parameters it takes, you can look at the constructor, okay, guys?
Okay.
And you can see here, arguments, caller, 3 lengths, name, so on and so forth, right? And you can keep going and going and going. I'm not going to get too crazy on it, but essentially, now you can do also the mood. So let's just say, is John happy? Like, what's the mood for John? Let's see, mood. Console.log. Unexpected token, where are you? Line 7. What did I mess up here? Oh. We all make mistakes, man. Okay, so John is 28 and he's happy. You see how it almost works exactly the same? Okay?
And then you use the word prototype to build up the mood.
Exactly. So the key point here is, the key takeaway is that the prototype lives on the parent object. So it lives on the constructor, okay? And when you call it, okay, what the prototype does is this. When a certain method or property, okay, is called, then what happens is it starts to search. The first thing it does is it searches the object, okay? It will go into the object, which is John. Does John have a method? No. Then it says, okay, if John doesn't have the method, then it's going to move on to the parent's object through the prototype. So what it says is, okay, who constructed me? Oh, it was this guy, person. Does person have this method or property? If the answer is yes, then you're going to call it. If the answer is no, what it will do is it will go to the object, the parent. Okay? At this point, there's no more prototypes. Okay? So if it doesn't go up, it's going to keep going up the prototype chain. Does Mary have this method? Nope. Does she have a mood? Nope. Go into the prototype. Oh, wait, here's mood, here's calculate age. Let's assume it wasn't there, it would jump to the next level. Okay, guys? Mm-hmm. And that's what we call the prototype chain. Okay?
Like a chain.
Exactly. It just cascades upwards. The prototype chain cascades upwards. Okay? As opposed to what other chain is there? You ever heard of the scope chain? Okay, the scope chain, you guys are very familiar with it. Can you call like a variable outside of a function, for example?
No, if it's only declared within the function.
Exactly. So that's what we call the scope chain. The scope chain, though, works top down. The prototype chain goes down up. So the scope chain goes from the parent down to its children. The prototype chain goes from the child all the way up to the parent. Okay, so these are two key fundamental differences that you guys need to be aware of. Okay, cool. So let's move on to something else. So let's comment all this stuff out. Next, okay, let's do another way to create an object. Remember I told you there was an object, right? So we can use something called Object.create. Okay? It's not very common, but it's kind of how React works under the hood. Okay, you guys ever heard of did you guys see the React docs at all? No, maybe?
No.
Okay, well it kind of works, it uses class.create. So classes use this kind of syntax because a class also can have a constructor inside, which is a little bit weird, but if you understand that the class uses Object.create and then you can use a constructor inside for a subclass, then it kind of starts to make sense. But so essentially, let's you guys kind of understand how the previous one works, right? Any questions from anybody who's on mute, like Nareen, Derek, or Celia?
I'm cool.
Awesome. Okay, if I'm going too fast, just let me know, man. I want to make sure that you guys get the most out of it, okay? I'm gonna fly a little bit through Object.create. It's not as important, but I want you to see the difference, okay? So let's say Object.create, let's start off with but it's basically a person proto. This is just arbitrary here, right? And how it works is it literally makes an object. So it accepts an object. This is very similar to this up here. You remember this?
Mm-hmm.
Right? So what it actually does is we're going to use, let's not do that. We'll say var John is equal to Object.create. Okay? And we'll say, person proto is equal to this object.
Do you mean var John or car John?
I definitely mean var. So,
Next one, Larry.
maybe John is a car, you never know. Okay, so let's do basically, okay, so let's give it the calculate age function here. Okay, this looks a little bit weird. I'll explain how it works after, but essentially what you do is in Object.create you use a key value pair, okay? And it accepts a prototype a little bit differently. So we're going to use the same function, which is 2018 minus this dot year of birth, right? Right? Okay, and all we're setting up is this is the prototype, right? And we're going to create an object. And so we're going to basically say object, create this one, and include the person proto. Okay, and let's add some, and then what we do is, because you see here, this is kind of like an object, right? Object.create accepts key value pairs, right? So what happens if you have an object? You can use the dot notation on it. So John's name is equal to John. And although I'm pretty bad with semicolons here. And then John has a year of birth, which is 1990, our good friend here. And he does go to work, and he does what? He is, I believe we said he was a teacher, right? Was that right? I don't know.
Mm-hmm.
Right, so let's console log. Cool. Does that look any different than the other one? It doesn't. And look at this. So let's do John now, dot calculate age. Let's invoke that. Look at that. This looks like a lot less code, and it is. And it looks a little bit funky, and it is. So let's just do it all in one shot here. So there's this is method 1. Okay, and I'm going to go over this, so just bear with me, okay? And this is method 2. And so let's use, what was our friend here? Who was it? Mary, right? I believe she had a little lamb. I'm not sure about that though. Not 100%. But let's use Mary here. And let's give, I'm just going to try to remember what her stuff was. So I'm going to say Object.create, right? Okay, and I'm going to pass in our prototype as well, person proto, right? And this is arbitrary, by the way, guys, the name. Okay, now, remember I said Object.create accepts a key value pair? You remember I said that? So if you have, let's say if you have this here, you could do John.name to get the name, right? Right? So that's kind of like how this one works, except you're doing assignment, because if it's an object and you do John.name equals something, it just creates it inside the object, right? But the way Object.create works, it accepts key value pairs. So it accepts a hash. And this is where it starts to get really weird. This is why I did the first method. Mary. I don't know why I said Jane. Okay, cool. Stop. Okay, and then what's her year of birth? Okay, another key value pair. So you have to specify the value. The syntax is a little bit weird, not gonna lie. I don't personally use this too much, but it was good to know because you will run into this. I guarantee you. You will look at legacy code and you will be wondering what in the world is going on. I believe, did I say she was a designer? Yeah. Cool. So let's do another log, right? Let's log Mary. And let's find out how old Mary is. Calculate age. Cool. Again, 2 methods, same constructor, same result. Okay? People will argue till they're blue in the face. Use this one. Use that one. Use this one. Honestly, it's your call, whichever one you feel comfortable. Personally, I find the syntax for method 2 is a little bit weird. It resembles a lot of, this is very C# style, where you have like an object or a hash, whatever you want to call it, and you get a key value pair, but the key accepts another object. Like very JSON-y, okay? Cool. So, quick question. I know this one was a little bit confusing. We're just touching on this one very briefly, so we can move on. Does anybody have any questions about this?
I'm good.
Derek?
I'm cool.
No, it's all good.
Nareen?
It's all good.
Okay. Honestly, guys, like this piece here, I think I cracked the computer screen banging my face against the keyboard trying to figure this one out. Like, honestly, it took me a little while to get this one, so don't beat yourself up over it, but it is something that you kind of need to be aware of because a lot of the ES6 stuff will use some of this stuff under the hood. Or if you go do like if you go look at some kind of a library and you're curious how a library works, you might see this stuff. Because a lot of the stuff that you guys are doing, like npm install this, npm install that, right? But even though it's being maintained, new features are being added to it. When you go to use it, maybe some of those methods are like from like 3-4 years ago, and it's doing something weird. You go to look at it and you're like, what the hell is this? This isn't JavaScript. Because you're used to writing ES6. So it is extremely valuable, especially for employability. You tell people, you know what, I know modern JavaScript, but I also know how modern JavaScript is built. So if somebody asks you, well, how do you make an object? You tell them, well, which method? Do you want Object.create? Do you want the object constructor? Do you want the ES6 syntax? What methodology do you guys use? And then you're going to see that immediately those people who are interviewing you or speaking to you, without even asking you another question, they immediately understand that you know more than just the fundamentals. You know more than just console log hello world. Or you know more than Slack Overflow copy paste. Like, you have a fundamental understanding of how this stuff works, which is a lot more than most people out there can say. I'll be honest with you. People with like all sorts of experience. Anyways, so remember I said that a constructor's prototype property is not the property of the constructor itself. It's the property of all instances that are created through it. Remember that googly goop that made absolutely no sense? Okay, so now that we've gone through these exercises, this is actually what that means. It means that when you create an object from a constructor, this prototype actually doesn't belong to this object. It belongs to the parent. That's all that means. So if you were to do like check to see if a prototype exists against it, it would come back false. Sorry, it would come back, if you check to see if this is a property of this object, it will come back false. If you check if it is a prototype of this object, it will come back true. Okay? This kind of logic is actually kind of helpful, especially when you're doing APIs. Okay? So again, just remember that a constructor's prototype property is not the property of the constructor itself. It's the property of all instances that are created through it. So let's say you make an API call. Google Maps. Everybody knows Google Maps. You're all going to use Google Maps, okay? Let's say you need to use Google Maps for whatever. So you make an API call to the Google Maps, you get a response, okay? There may be methods in that object, but they're not exactly direct properties of the object. So you can't access it by like checking the object and inspecting it. But they're accessible through the prototype. Okay? And that's the power of prototypes. That is one of the fundamental reasons why they're also used, so that you can ship methods along for the ride without actually having to write the method on those particular instances. Okay? Someone's typing hard there, holy. Cool. So,
I was wondering, how do you reference a prototype if you want to find the value?
you use the same dot notation, because what happens is, if I want to use calculate age, you see how I use calculate age?
Okay, yeah.
Because what happens is, it says you run calculate Mary's age. It's going to say, okay, calculate age. Oh wait, it's not here. Okay, check here first. Oh, here it is, run it.
Okay. So you have to go to if you don't have the code and you're just looking at the console, you have to go to the to the prototype
Yep.
section, and then it will let you know if it has any.
Yep, like let's use 1, 2, 3 again. 1, 2, our favorite 1, 2, 3. Whatever, let's just use 2, right? So when you call a.length, right? Actually, length is a property. But let's say you do a dot push 4, right? Well, where's 4? 4 is not a property. Only length is a property, right? But if you do a, you got it. How did that work? Well, it goes, okay, well, push is not a property. It must be in the prototype. And then it goes through the prototype and says, oh, there it is. Wherever it was, I just overwent. There it goes, okay, here's push. And then inside the prototype, you can even go inside further and it tells you what it needs. And inside that, you find other things. Look, bind. And it has call. This is also very important. And then that in itself has another prototype, which then that one has a prototype. And then you get the point. And now we're at the end of the prototype chain.
Is that what they mean when they say like first level functions and stuff like that?
No, so actually that's what we're going to go into next. Cool. So it's a good precursor. So first level function, like first class citizen functions is the best way to put it. They're like first class citizens. But before we can do that, let's take a look at a couple of things. I know I touched on primitives and objects, right? So let's just take a quick look to understand how some of this stuff works and to understand where we're going with this. Let's take a look at primitives versus objects. Okay, cool. So what is a primitive? Anybody?
The data types.
Cool, yeah. And an object is anything in JavaScript. So why are we even looking at this? Like what the hell? So basically, var a is equal to 23, right? Cool. Okay, so let's just log a, right? And let's do var b is equal to a, right? Let's console log, come on, b. Cool. What do you think is going to happen?
23.
Exactly, right? Cool. So we're on board. Now now this is not a declaration, we're just going to assign a value to a, right? Let's just say, I don't know, 50, right? So using the same logic, we should get 50 and 50, right? Well, we should get, exactly, sorry, my bad. Now, why is that? Because, well, it's kind of. So basically, you get a, you console log a, right? And then you say, okay, b is equal to a, so you reassign it. But when you console log b, at that moment, it's 23. So yeah, it's synchronous. Now, let's take it one step further, right? So what does this actually mean? It means, because look at a, the original value of a is 23, right?
Yeah, but it makes a 50 and then b 23.
Right? So at this point, b is 23, right? So what does that actually mean? It means that a primitive actually saves the value, okay? So basically, a is a saved value and b is a saved value. So if I could do whatever I want to a and it will never impact b, right? I could do a is equal to whatever. Maybe not that, right?
And then you reassign them.
Right? But b will always stay the same, right? Right? So it will always stay the same. B will not change. Why? Because we save the value of a into b. Okay? Now, well, why does this even matter? You probably ask me, like, what the hell? Well, this is primitives, right? This is the behavior of primitives. not something that they really touched super amounts in the class. We kind of went, well, this is a primitive. This is what it does. Okay, and we moved on, right? But let's compare it to an object. Now we're getting into. I know it's counterintuitive because we're like, oh, we're just doing like little simple stuff, and it's supposed to be advanced JavaScript. But this is actually some of the weird parts of JavaScript. These are some of the most advanced concepts of how JavaScript works. And what that is, it says is object one, right? Let's say object one is equal to our friend John, right? Name is equal to John, right? Nothing fancy here, right? And let's say his age is 26, or how old was he? He was 28. He was 28. I'm pretty sure he was 28, right? Cool. So let's use the same logic, guys. Let's just say var object2, right, is equal to what? Object 1, right? Right? Same logic, right? So let's console log object 1, right? And let's console log object 2, right? Let's do a little break here. Log. I feel like it's Space Invaders when I do that. Cool. So, same deal. We're like, hey, intuitively, this makes sense, right? What happens now when we do object1 dot age is equal to 30? Before I do this, what do you think is going to happen?
It will update both objects.
Object 2 will be the only one affected, I think.
Somebody said it. Who said that? Mark?
Object 1 will change, yeah.
I think was it Ahmed who said that?
Yeah, I said that will update both objects, object 1 and object 2.
Okay, because this is the first time you've spoken in a while, so I recognize your voice, my friend. I'm like a ninja. So Ahmed is actually right. Why is that? Ahmed, why is that?
Okay, because, well, I only know because I used it before. To be honest, that happened before.
Cool. Okay, so you learned through.
If you say one object equals another object, the update of the data of one object will always reflect on the other. That's the way I know.
Okay, so let's expand that. So Ahmed, listen guys, most of the stuff that I learned was literally through trial and error and code. I don't know, man. When I was in a boot camp myself. I told Martin the story, I told Celia the story, and like literally, and I was in a full-time boot camp. Okay, I was learning Ruby. They didn't teach me any JavaScript. I had to take it upon myself to learn all of this. Okay, well, at least the more advanced portions, especially. And I remember I used to go to like school at like 8 or some super early in the morning. I used to go to sleep at like 3, 4 in the morning. So I'd like code, don't sleep. I think I didn't sleep for at least like 6 months straight. So I was like a zombie. But the reason why, and I mentioned this to the other guys, is in my mindset, the only way I could catch up to people who have industry experience and stand toe to toe with them was to invest the time in myself, right? So if I go to a job interview and they're like, well, you only have so and so experience, I said, yeah, but look at how many hours I put into GitHub. Your most junior dev, how many hours does he have on his GitHub? And believe me, they'll check. And when they'll call you back right away, they'll be like, yeah, so when would you like to come in for technical? Like, it's crazy stuff, right? Like, obviously, a little bit more gentrified, the statement. You know, not as straightforward, but that's the message. Anyways, so to expand on Ahmed's explanation, which was very good, Ahmed, what happens is when you have an object, the main difference between a primitive and an object is that a primitive saves the value into the variable. The object does not. Okay? What the object does is when you instantiate the object, okay, you actually say, hey, reserve this object in memory. Okay? When I reassign it to object 2, you actually do not make a copy. This makes a copy. This does not. So what actually ends up happening is all you do is point. So imagine, like, you know that annoying kid that always points when he's talking to you? That's basically what this is doing. You're pointing at someone and that person's like, me? No, not me, him. And that's essentially how it works. Maybe that analogy is not the greatest, but that's how it works. You cannot save the object into another variable. You can only point in the direction in the memory where it lives. That is why when you update one object, it updates both, because this is actually not anything saved. Okay, does that make sense? Cool. Now, let's say we're done with that. That's pretty much, okay, so that was one of the key concepts that I want you guys to understand. This will help you debug things a lot, okay? If you understand this so far, you're like considerably further ahead than you think you are, trust me. Okay, so let's talk a little bit about maybe some functions. Okay, so let's say let me just think about what we're going to do here. Okay, so let's make a function here. Let's make a function here that will, let's just say var age is 27. I don't know, whatever. Let's say var object is equal to, let's just say a new person. Let's just say me. I don't know, whatever. Let's do it. Let's say the city we're in is, I don't know, T dot, right? I hope. And let's call this one done. Okay. So we're going to use a function here to change the object. Let's give this a shot here. Let's see, function. Let's call it change. Okay, and it's going to take in 2 random parameters, okay? Anonymous parameters. They're like arbitrary, okay? Let's say age is equal to 30. And then let's say b.city is equal to, I don't know, Montreal. Let's say change. Let's invoke this and let's do age and object. Okay? So what are we doing here? We are, let's do this console log here. Cool. doesn't it? That's weird. As far as I'm concerned, A is there, but whatever. Okay, so we made a variable. It's a primitive, right? We're still on that. So let's combine the two and let's see how they behave. That's essentially what we're doing here, okay? So we made a primitive, we made an object, right? And then we're going to use a function to manipulate it, right? We're going to call the function. We're going to pass in, because it takes A and B, arbitrary, right? And A is equal to age, B is equal to the object, and what we're going to say is age is going to be equal to 30, and the object city is going to equal to Montreal. What we're going to do is we're just going to log the age, and we're going to log find. We're going to log the object.city. Cool. So my best advice is when you're working with modifying the objects, like primitives, okay, you try making a function that takes in something and then modifies it, okay? And then let it spit out something new. Kind of like how this little ditty worked, okay? This wasn't too crazy. It was just to give you like a little bit of a taste of how objects really work under the hood, and that at the end of the day, when you create an object, when you first create it, it saves it in memory. From then on, it will never be the same. As a matter of fact, we'll prove it to you right here. Object 1, object 2, they're the same, right? These two are the same, right?
Yeah.
Okay, let's do this. Let's get rid of all of this stuff. Okay, so object 1, object 2 are this. As far as we're concerned, intuitively, they're the same. So we're going to say if object 1 is equal to object 2, right? We're going to say return true, right? Else return false, right? And actually, let's do a log true. Log. Otherwise, we'll never know what the heck is going on, right? You see that? This is exactly why we use map. Okay? Again, because everything in JavaScript is an object, if you use anything other than a primitive, you will never have an equality because they never create a copy of each other. That's why when you're using like arrays, that's why like arrays, for example, you're always going to use a map. That's why map is so popular. You see map everywhere. You guys are going to be doing React. Mark my words, you're going to live, eat, and breathe map like you wouldn't believe. Hold on, what does it say? Does everyone scratchy noise? You said there's wind coming from someone? Is this better?
Oh, much better.
Okay, 1 second here, 1 second here.
Hello, people.
Is that better?
Yes.
Okay, shoot, you should have told me. It would have been, I just happened to look at chat. Oddly enough. I have it open, spying on you guys in case you're talking bad stuff about me. Just kidding. You can say whatever you want about me. You know, I'm used to it. Okay, cool. So you're with me on this, right? Cool. All right, so we're going to get now that we've got this out of the way, if we're going to get into some of the fun stuff here. I mean, I found the last stuff really fun because it's like just weird. So I find like little quirks relatively entertaining. So my advice to you guys when you're learning something, try to hook into something that you find like somewhat interesting or fun or whatever, and then just grind it away. And try to find like, I try to find a double positive out of anything. Even if it's tedious, I try to find something that's gonna hook me in. Otherwise you're just gonna burn out, you know what I mean? And you guys are doing this A, to get a job, and B, because you want a job that you're gonna enjoy doing, right? So, I mean, obviously it's about the money too, but if you don't find these little wins in your day-to-day, you're gonna burn out the same way you burnt out in your other jobs. Okay, so just heed that advice that you kind of have to find different ways to keep yourself engaged and motivated, okay? Cool. So let's do the fun stuff. First class citizens, which is functions as first class citizens. And what does that mean? It means that a function can do a few things. So the first part is passing functions as arguments. Now you guys have done this before, right? Right? You guys have like, especially like all the callback. Like this is basically a callback in its rawest form. So let's just go over here. Let's do an array of years. Let's use our fun people here, 1965, I don't know, 1937, I don't know, 2005, and I don't know, 98. Let's call it a day. I think that's enough. Cool. So what are we gonna do? We're gonna do some fun stuff here. So let's go back to calculate age. Let's go to our good old trusty function here. Yeah, let's do that. Function name is calculate age, right? And it's going to take, and this is where it starts to get a little bit tricky. We're not going to pass in anything special. What we're going to do is we're going to create modularity. Okay? Has anybody taught you modular patterns? Okay, anybody else?
No.
Okay. Modular patterns are super, super, super important. Especially like ES6 now has modules introduced. Modules can also be redefined as components. So where did you guys hear components? React. Thanks, Celia. I knew you would do something like that. So basically, we need modular patterns in order to kind of write modern JavaScript. So the weird thing is, it gets a little bit tricky when you start working it because it's a little bit abstract, but once you get used to it, it actually becomes really, really powerful. So what we're gonna do here is we're gonna just do something super, super simple, and I'm a big, like the way modular pattern works is make a function that does one thing, but it does that one thing really, really well. Why is that important? If anything breaks, it is super easy to figure it out. Like you can make a calculate age, like I think what I'm gonna do here is we're gonna figure out like, I don't know, different stuff with the age. Like, I don't know, let's figure out like what's the age of majority. I don't know, like anything else. Anybody here ever try to calculate maximum heart rate or something? Anybody here work out?
Yes.
Okay, cool. So there's a couple of things like, so you can kind of figure out, I think maximum heart rate, there's a formula for it. Max heart rate per age, yes. 20 beats per minute, 30 years. Cool, so we're gonna try to get this from this, okay guys? Does that make sense?
Yep.
Cool, so this is like a super simple problem, but it has some real world implication. Like you could get, hey, calculate such and such from an array. So I'm gonna do, and it doesn't matter what I could use. In this case, I'm gonna calculate this. I could calculate how old you are or whatever. So my method is gonna do just one thing really, really good, which is it's gonna take an array and a callback function. Okay? Do you guys still hear the wind, by the way?
No, it's fine.
It's very subtle now.
Sorry, what was the last person?
It's very subtle now. Like it's not a good.
Okay, cool. Cool, so I had to close the window. That was the issue, by the way. It was like, apparently wind was coming straight into the mic. Cool, so let's just get started here. So let's just say it takes an array, right? The array is equal to, actually array response, right? So let's just say the response is going to be, or the return, whatever, right, is going to be an empty array. And let's just use a for loop. You guys have been using for loops, right? Mm-hmm. All right, so let the index, actually let's just do it manually here. Okay, for, right? You guys are used to this. I'm going to say for the index while at 0, right? And while it's less than the length of the array. Does this look familiar? You see how we're calling length here? That's part of the magic that I was trying to debug or defunk, right? And then, you know, regular incrementation, nothing crazy here, okay? Now, all we're gonna do is for the response array, I'm going to push, okay? What am I gonna push? I'm gonna push, and bear with me here, you're gonna see how this all works. I'm gonna push this callback function. And what this callback function is gonna accept, it's gonna accept the particular iteration in the array. You guys know what this means right here, right?
Yeah.
Okay, so let's walk through this here slowly. Okay, because we're getting into more complicated stuff here, but this is still simple but complicated. We have an array, and we have a function that's going to calculate the age based on an array that we pass in. And actually, we're not even going to do that. Let's just say array calculator. Yeah. Let's say array calculator, right? I'm going to make it even more generic, actually. So this function takes an array and a callback. What we're going to do is we're going to loop through that array, and for each item in the array, we're going to pass that to another function, which is the callback. The result of that evaluation, we're going to push to our response. When we're done, we're going to return that particular array. Okay? Now we're starting to get in the thick of functional programming here. Cool?
In this case, like, what is the callback? What is the function of the callback in this case?
We haven't done that. So now we're going to do the callback. So let's think of, I don't know, let's do like 2 or 3 callbacks actually. Okay? So what's our first callback? Let's go to our trusty calculate age. You remember this one? Right? So we're going to return 2018 minus some element. This is arbitrary. I'm just going to call it an element, whatever, right? So whatever we pass in here, which is this, you see this? That's going to be our element. So whatever we would pass in, we're going to subtract from 2018. So let's walk through it again. We're going to pass in the year. We're going to pass in the function. We're going to loop through the function. So the first iteration, while I0, is going to be 1990. I'm going to pass 1990 to calculate age. Calculate age will then say, okay, the year minus 1990 will give us 28, right? So it's going to push 28. So this represents an evaluation. It will push that evaluation into our new array, and then we're going to have that. Okay? So let's do a couple of more functions. Let's say, I don't know, is drinking age. Let's say that also takes an element, right? And we're going to return only the element, that is greater or equal to 19, right? I think it's 19. It's been a while. Not that old, but still feel old. Cool. Okay, so these are two super simple functions. I'm just going to start off with some simple stuff, okay? Cool. So let's take a quick look here on what we're going to do. Okay, so let's, before we get into this one here, the maximum heart rate, because this one's a little bit more complicated. Calculation. Cool. Okay, so we're going to say, let's just say the ages, right? Because it's an array, we're going to use plural, is going to be array calc, right? We're going to pass in what? The array, correct? Let's just say, okay, we're going to pass in the array, and we're going to pass in, what should I pass in as the callback function, guys? What should I pass in? Anybody?
Something about the drinking.
I'm sorry?
Something about the drinking. Like if it's 19 years old, we can say that someone can drink something.
Not exactly. So we could do.
I tried.
No, don't worry. Don't worry. What you're referring to is this array calc year and then we're going to pass in is drinking age. So using this one, what would you do for the top one? I should have specified. Okay, let's just say drinking age.
Should be calculate age.
And this is, okay, cool. That was, I think, Ahmed?
That's right.
Okay, so let's say age sum or ages calculated. Let's be a little bit more verbose about what we're trying to do, right? Cool. So we're going to say now ages, no, we're going to pass in calculate age. All right. So right now we haven't done anything, right? We haven't done anything. So I'm just going to invoke it, or I'm going to call it, because what does this actually represent? This represents the evaluation of this whole function. Okay? As you can see, I'm not directly passing anything to this function. This function is a blank canvas. I can give it whatever I want. This function, all it does is take in an array and a callback and does something with it. So I can create any other function and pass that information to it. Okay? Same function will yield me two totally different results. This is the power of modularity. This is also a precursor to what you're going to be doing in React. Because React is components, which is also modules. Okay? So let's just do ages calculated, right? And let's just do here, let's do a log here of drinking age. Is that even right? Yep. Cool. Let's make this person, actually, no. I think this person should not be allowed to drink. What do we say? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 is greater or equal to 19. Return. That's kind of weird. This one gave me an unexpected result. Why?
Do you have to convert it to int?
No. This is just a conditional. Is, let's just say, less than, only if the element is greater to. Huh. Weird. It shouldn't do that. But, okay. I'll play with it later. But, I mean, you get the point here. You see how it returns two different things here? Calculates the ages, and then it goes through the conditional.
You could use filter for that.
Right, I know you could use filter, right? But the thing is, you can actually write one giant function that does all of this too. But that's not the point. These are we're trying to use super simple functions so that we can see how this stuff kind of works under the hood, right? So let's on that note, let's make something a little bit more complicated. What are we doing? We're doing max heart rate, right? Formula. Maximum heart rate by age formula. Equation. So it is.
I know what the problem is. It's because your is drinking age method takes the year they were born, not their age. So the element that's getting passed is the year they were born.
Yes, this is true. This is true.
Dirt. Nice.
This is true. Cool. Okay, so in this case, I mean, we could play with it a little bit more. Like, we could do pass and calculated age, and then pass it a conditional, but we'll leave it as is for now. But good catch, man. Who said that, by the way? Ahmed?
That was Derek, I guess.
That was Derek? Oh, sweet, dude. When you say something, make it count. I like it. Okay. Equation number 1, advanced topics. I'm going to go with. Okay, cool. Between the ages of 18 and 81, why is this so complicated? That was a weird equation. Maximum heart rate, understanding, okay. Does anybody know the equation off the top of my head? Off the top of their head? Probably not, eh? Okay. It is recommended to exercise with 100% formula. Mathematical formula. Let me see. I think I saved it. Let's check here. Okay. Okay, I got it here. Cool. So it's going to be a little bit tricky. So bear with me, okay? Max heart rate. It's going to take what? It's going to take an element, right? And this particular element, we need what? We need a condition, right? We need a if statement. We need an if else. By the way, I'm lazy. You see, I'm just using code snippets. I recommend you write it out. But are you guys using code snippets? No?
No.
Not for JavaScript.
Yeah, get on that, guys. Get on that.
Send us the link.
Okay. On next Wednesday, I'm going to put this as a takeaway. I got 2 takeaways. Somebody was interested in doing scraping. And the other takeaway will be, I'm going to go through all my VS Code extensions, plugins, setup. And you see my terminal?
Yeah.
And we can go through the terminal as well, if you're interested.
Yes.
Because I'm assuming you guys like that. Like, right? And then I just go desktop, whatever.
Is that ZSH?
Nope, this is Bash.
Oh, okay.
But you can, a lot of people use Zesh, Bash. I mean, they're all the same. It just comes down to how you want to customize it. I wrote scripts that do this to modify a theme that I downloaded. Anyways, okay, cool. So if you are greater or equal to 18 and you're less than or equal to 81, then I want to return, I believe we have to round this. Math.round. You guys ever use math.round? I think you did, right? 206.9 minus another equation, which is 0.67 multiplied by the element. Else return -1. Okay, this is the formula. I'm not, like, I didn't just randomly make this up. And I'm just rounding it down so that we don't have to deal with floats, okay? I'm just saying, look, just round this. This is the formula, and it's this number, which is maximum, I think maximum heart rate, minus like a coefficient against your age. Cool? And then if it's not true, then we're just going to return -1. So let's do var max heart rate is equal to array calc years dot max heart rate. Now I think we might have a problem with the year thing again.
The element will still be year, and it's gonna be always over more than 81.
Yeah, so there's going to be, it's never going to be between these two. So I guess I have to call, I guess I would have to call calculate age. Okay, cool. Anyways, there's a small bug. We could try debugging it, but you guys get the point here, right? The point here is that we're going to take a function, pass stuff into it, and then it will just call. So it doesn't matter what I write, it will always go into it and run that function against it. Does that make sense? Aside from the bug, because we're running low on time, so I just don't want to kill time debugging something if we're just understanding the key concept of it. Questions? No? Hello?
Good.
No, I'm good.
I'm good.
Derek?
Yep, everything's good.
Sweet. Okay. There is another portion here which, okay, the next one here, we're going to take this to another level here, okay? Let's do the next one and then we're going to stop there. We're going to go a little bit over time. You're okay with that? Are you guys okay with that?
Yep, good for
Okay,
me.
yeah, sure.
Yeah, sure.
Cool. Are you finding this stuff helpful? Like, is this kind of
Very helpful.
cool? And I'm trying to like make these complicated concepts as simple as possible, and trying to make them relate to what you're going to be working on next, right? Because, like I said, you guys are going to be running into a lot of different issues that if this stuff doesn't make sense, then it will be super impossible to debug. Okay, anyways, so have you guys done functions returning functions? Have you guys done that yet?
No.
Functions returning functions. Okay? So, I mentioned earlier, functions are first-class citizens, right? And part of that behavior is that a function can accept a function as an argument. A function can be stored as a variable, which you guys know, which is right here. Also, a function can return a function. Now, this is a little bit weird, and it's going to take a few rounds of doing it. And I suggest, like, everything that we've done has led up to this, and then there's another concept after that, but we won't have time for that, which is called an immediately evocable function expression. And that is a lot of fun. Anyway, so let's get started here. So let's just say, let's go back to, let's do something a little bit different here. Let's create, I don't know, a quiz. I don't know, let's say interview questions. Did I spell that right? Interview, oh yeah, I hope so. Fail. Okay, an interview question is going to take a job, right? And now, let's think about this. Okay, let's create the job. Remember how we did the objects where people had jobs and whatever? Right here. Remember these guys? Mary, John, and Mark, who was a teacher, designer, and okay, well, forget about Mark. He's retired. Forget him. So what we're going to do is, okay, so if the job, so we're going to pass in a job, just whatever we pass into this function, if that particular thing is equal to a designer, then we're going to return a function. Okay? Now, this function is anonymous, it does not take any name. We're just going to return just a straight pure function, okay? Now this looks a little bit weird. Has anybody done any of this? No? Yes?
Me, no.
Derek, you have an exposure to this?
Not for a couple months, but it looks vaguely familiar.
Okay. Okay, cool. So you're gonna end up with a lot of this. This is actually a super common pattern where you'll basically reach out to a function or something, some kind of functionality, and then it will come back and give you another function that you would then call that. So whatever the return of this particular if statement or a switch case or whatever it may be, the value is not going to be like a final computed value. You're going to come back and get something that you would have to then execute. Okay? So we're going to return a function, and that function is going to take, I don't know, let's just say it takes a name. And we're going to console log that. Okay, we're going to use template literals here. You guys did a little bit of template literals? No? Yes?
Yep.
Cool. I'm just lazy. I just don't want to do this. I don't want to do name plus some string, like lazy. I think I mentioned lazy programmer is the best programmer, trust me. It means that you will find a way to make your life easier. In other words, you'll be more efficient that way. Okay, so if it's an interview question and you're a designer, let's just say, can you please explain or define UI, UX, right? That's a fair interview question for a designer. I don't know, I'm not a designer. Okay, cool. Okay, let's add another one here. Else if the job is equal to, I don't know, what did we have? We had a teacher, right? We had a teacher, I think. Cool. So if you're a teacher, let's return, again, a function, okay, that accepts also a name, right? And it's all that function is going to do is just console log the name again, right? It's going to take the name and okay, let's just say, okay, what is okay, whatever, so and so, what is your strongest subject? Is that a fair question? I don't know. Okay, and now, oops, not here. By the way, you see how I have bracket colorizer? You see that?
Yeah.
Do you guys have that at all? If you don't, get it. See how each bracket has a different color? That's how I knew I was in the wrong spot without even anything being highlighted. You see how it underlines it for me? Sweet.
That's very cool.
It's,
Send the link.
yeah, it's like
Yeah, send the link.
yeah, I don't know, man. According to Celia, I'm weird, so I may not send the link. I don't know. I'm gonna be weird like that.
Take it back, Julia.
Okay, I need to mute myself.
Sorry, Celia. Sorry, I had to. Okay, so we're gonna return. We're gonna do the same thing. It's gonna return an anonymous function, and all this one is saying is, I don't know, what the heck? Where's my? It's weird. It's not giving me any code completion. That's fine. Console.log. And then on here, we're gonna take a name again. And all we're gonna say here is, hey, whoever you are, right? I think it's to be what is it that you do exactly? I don't know. Basically, if you don't have a job, what kind of job do you have? I don't know if that makes any sense. But okay, cool. So let's dissect this a little bit. I know this probably looks, you're probably asking yourself like, what the hell is this guy doing right now? Like, well, how is this even relevant? Well, what happens is you're going to end up again with a lot of situations where you have like some software and it's going to accept, I don't know, let's just say you're making a call to an API or somebody makes a call to your app, and then you're going to get a parameter out of it. In this case, I don't know, let's just say it's a job, right? And what you're going to do is based on that particular response, that whether it's a query or you send out an AJAX call, you get a response back, and you're like, okay, now I have this particular item that I saved in a variable, whatever the case may be, you're going to want to do something with it. Now, you're not sure what you're going to do with it, but you want to pass that to a function. So you want to do something with a method based on the response you get back. That is where this type of design pattern becomes valuable, okay? And I know this one is like really simple and dumbed down in terms of like what it actually does, but if you can look past it and then just understand like, hey, I get a response from an AJAX call. If that AJAX call says that like, oh, the object I got from the back end is a designer, then all designers, I'm going to create this U of T quiz. And these are going to be the questions. So I can keep asking questions. Okay, does that kind of make sense? Yes, no?
Yeah, makes
Yes,
sense to me.
yes, yes.
Okay, okay. Cool. So, how do we even access this stuff? We can't, like, if we do, I don't know, if we do, for example, for a teacher question, right? And let's say teacher question is equal to interview questions, right? The function. And let's say we pass it teacher, right? Let's say we get a log here. Let's just console log teacher question. Why am I not getting code completion here? It's annoying. Anyways, whatever. Okay. Cool. Look what we got here. Does this make sense? Like intuitively, based on what your understanding of this, does this return make sense? If it doesn't, what were you expecting? Let's go with Martin. What do you think, Martin?
Can you repeat one more time the question?
So all I did was I created this function, and then I said, okay, I want teacher question. I'm going to call the function and pass in a teacher, which would then execute this if statement.
Yeah.
So when I console log, I'm expecting to console log something, right? But when I console log this particular statement, I get this. Oops. Now, my question to you is, intuitively, does this make sense? If yes, why? If not, why? I didn't mean to put you on the spot, but.
No. Yes, it makes sense.
Okay. And why? Help the others out.
It's kind of like a switch statement it's finding a lot. It's basically the logic that you put there is if that criteria complies, if the job is equal to, in this case, a teacher, the string teacher, then execute the following. So in this case, you pass a string with the teacher value, and with the teacher string, and then it just matched with the logic on the second statement, on the second function. So it complies with that criteria. They match it, and that's why it consoles what is your strongest subject. Whereas opposing the first one, it didn't match because you have another position, another.
Okay. What if I were
string.
What if I were to tell you you were almost right?
It returned a function.
Right. So Naren is, based on your answer, Naren was able to kind of deduce here. Ahmed, you have something to add?
Well, I think it's returning the function because it's not running the function. Name, like the argument in the function is not given, and as a result, it's not being run. So it did the first part as expected, which is doing going through the F statement, matching the job with the string teacher, returning the correct, or returning going to the correct F statement and running it right, which is basically if job equals teacher, return blah blah blah, which is exactly the part that you just highlighted. But instead of actually running the function, which is function name console.log, what we should see is, for example, Alex, what is your strongest subject? That's what we should see.
Exactly.
And instead, we're seeing function name. We're seeing the actual syntax that we've written is being returned to us.
Exactly. And Martin, that was kind of a trick question. Sorry, man. I didn't even put you under the bus a little bit, you know?
No, not at all. I was just like doing something else. I didn't see fully the what we were doing. Yeah, it makes sense now that I looked at it deeper scale, the return function. Yeah.
Yeah. So essentially, this is actually just a return function, and it's this. Believe it or not, this is actually returning a function expression. Okay? Do you remember very early on we talked about function declaration versus function expression?
Mm-hmm.
Right? So a declaration is saying function name, log, something. Right? This is a declaration. When JavaScript runs the execution, top down, it hoists all the variables up, initializes them, okay? Then it goes through the execution stack and calls the functions, okay? So what's the difference between var sum fn is equal to okay, so I mean technically these are the same thing, right? If I run both, you're going to get the same console log, and somehow I managed to mess up the spelling on both. Apparently they're the same. Such is life. So technically the result is the same, but they're not the same. This is actually an expression and this is a declaration. So when you run through the execution stack, this will get loaded up first as undefined, and then this one would load up. Okay? Just little small tidbit on the execution stack for JavaScript. So, having said that, basically we can pass this in as a variable anywhere else. So where does that matter? So let's just duplicate this. Let's duplicate this and let's make the other one, which is a design question, right? And a designer, right? Cool. So we basically have one generic function, which is the interview question, and then we just create a whole bunch of other functions, right? So how does that work? So basically, now that we return a function, how do you execute a function? You do a function, right? You do a function like that, right? That's invocation, right? We're all on board. We've seen this before. It's the same way this works, right? So basically, when a function returns a function, in order to complete this execution, in order to actually extract the value from this design pattern, and this is, by the way, like very, very functional programming. You would go, now that we have this declaration, we go design question, let's say teacher question, right? And this is going to be a little bit weird, but because this returns a function, so it's actually a function, this variable becomes another function, we can now go, let's say, Mark. And let's say, Mary. Look at that. Isn't that weird? Why does that work? Well, I kept this here for a reason. So whenever you have a function that returns a function, okay guys, and this is like super critical, and you're gonna see this a lot. And this is just the tip of the iceberg. Whenever you see this type of pattern, in order for you to extract the value that comes within, you must invoke the first layer and then go into the second layer. Okay? Now, we're going to do something a little bit weird here. What if I could tell you, you don't even need this? You don't even need this. I'll show you why. Let's say you do interview question, right? And let's say you take the teacher, right? And then let's say you take Jimmy. Look at that. Okay? Have you ever seen this before? Do you know what this is called? This is, I'll finish it up for you guys. This is getting into something called closure. Have you guys ever heard about closure? Have you worked with closures?
It was mentioned in class a few months ago, but we didn't. I don't recall getting too deep into it.
Okay. This pattern, along with this type of invocation, okay guys, you're gonna see this a lot in Node, okay? So this is actually, we're gonna kind of like finish off here. I did want to do something called an iffy, and then get into closures, but I think this is a lot already. Like, how are you guys feeling about this?
Yeah.
It's good.
Okay.
I have
Like-
a question.
Yeah, what's up?
You know on line 189?
This one?
Yes. When you run, how come it doesn't show the function? After you put in 192 and 193, it shows the questions, right? But how come it doesn't show the function first and then the question?
Ah, okay, okay. So, that's a valid question. So this here,
Okay, no. I think because your console log is at the bottom. Is that why?
nope. Oh, you
Console
mean,
log.
you're wondering about this one?
Yes. Okay, so
Well, I kept the console log in order for you to see, here's the evaluation and how you extract the value, and this is actually what you're calling. So what actually ends up happening is you're calling two functions in succession. Like if I return, and you can return a function that returns a function that returns a function that returns a function that returns a, and so on and so on and so on. Okay? You guys, at the further you go into Node, the more you're going to see this. Okay? Especially this. I don't know if anybody said, but people talk about like callback hell. You guys ever heard that term? Okay, that is actually what it's calling, what it's specifically discussing. It's when you have functions that return functions that have a function that then calls another function, and that return function has like 4 other, like it just keeps going and going. So like you get like an error and you're looking at it, and then you have to go to like 10 different files that then have functions that go to 10 other files that then loop back to the original file that then call 2 other, like it just goes crazy. Which is why modular patterns became really, really popular. But the more you guys are going to be doing Node on the back end, right? That's the whole point of this course. It's Mongo, Express, React, and Node. This is what the ecosystem that you're going to be working with in Node a lot. Like a lot. And unless you get comfortable with these kind of design patterns and styles of functional programming, you guys are going to have a hard time. Either A, you're going to gravitate towards front-end programming with React or other types of front-end frameworks, and you're going to be like, screw the back end, I don't want to deal nothing with it. Sorry? Sorry, can you repeat that?
I think Ahmed was talking to someone else.
Oh, okay. Anyways, yeah, the point is that it's gonna get to a point where you guys will either make a decision that, hey, maybe I want to be a front-end developer for a little while and work with front-end frameworks and not deal with this kind of stuff a lot, and then do like React and whatever else, or you're gonna go back in and then transition forward. I would tell you most people, especially JavaScript, most people will gravitate towards front-end jobs because there's a high demand for that, and then they push towards the back end once they get really comfortable with modern JavaScript and how it works under the hood. Like this stuff here, I'll be honest with you, this here, it was like one of the hardest things to understand for me. Now, I didn't have the luxury of someone telling me or showing me, so I just had to like plow through like broken code for like hours until finally something worked. And I was like, holy shit, what the hell? But, I mean, it is what it is. You're gonna encounter it. Even as a front-end developer, you're gonna have to plug into the back end somewhere. So you can't run away from it, you can't avoid it. You kind of have to be aware of it and then take it from there, okay? Yeah, cool. So what I'll do is, let's finish it here. Let me just see what else. I'm just looking through my personal notes here of stuff that I wrote down that I wanted to do. I just really wanted to do closures and ifs. An if is basically an expression, but you need parentheses in order to trick JavaScript. Okay, let's just do an ify here. Kind of works the same way. Are you guys down, or are you feeling burnt out?
I'll be here as long as you are.
Oh man, trust me, I could be here all night, buddy.
Do it.
It looks like it.
all right. That means we're having fun, even though I'm like taking you on for like a deep dive here. Cool. So, okay, let's do one more. Let's see how we feel. Okay, so let's do ifs. Just give me a second. I'm just gonna blow my nose, okay? Apologize. All right, cool. Sorry about that. It's like allergies. They start to kill me near the end of the summer. Okay, cool. So what is iffy? It's an immediately invocable function expression. Now, let's take a quick look here. Okay, it's basically a function that runs as soon as it's defined. Okay, it's a design pattern which is known as self-executing anonymous function, which is just a fancy way of saying as soon as it gets to this code, it will run it immediately. Okay? Why is that even a thing? It's because it prevents the access of the variables. Okay? Why is that? Because it stops the pollution of the global scope. What does that even mean? Okay. Cool. So let's console log the window. Let's just say the window object, right? Everybody's familiar with the window object, right? Cool. So actually, let's use a for loop here. This is a good indicator. It doesn't matter what it is. Just say, I don't know, index is greater than, I don't know, 10, right? And then all I want to do is log the index. Cool? Simple, right? Right? Makes sense, right? Let's just use var here. Stick to our same convention. If I now console log index, what do you think I'm going to get? Let's do this here.
Okay. Or 9.
You're going to get 10. You're correct. Here's the reason. You see here, undefined. Here, it's 10. Because it's gone through the loop. Now, because it starts at 0 and you add 1, right? So, why is that even important? Well, one of the things that you have to keep in mind is something called variable scope leak. Okay? If you have a function, right, and you do var I is equal to 100, right, and you log I, right, and then you call the function name, right? You see how it's different, right? That makes sense. Intuitively, that makes perfect sense, right? But why does a loop not do that? Does anybody know why? No? You answered the question, Martin.
Can you repeat again the question?
If you see here, this behavior,
Yeah.
right? This is the behavior. Before the loop, index is undefined because it makes sense. It hasn't been initialized in any way, right? So hoisting will bring it up and we'll say, okay, it's undefined, it's nothing. You get a falsy value. Then we define it inside our loop, we console log it, so we go all the way to 9. Let's do this, right? We go all the way to 9, right? And then, so the last iteration is 10, then we console log, and then all of a sudden it's 10. Intuitively, you would think that it acts like a function, right? Like like this one. If you console log, like see this I? I is 100. It's not impacted by this because of scope, right?
Yeah.
So what does that actually mean? It means that if you have something outside of a function, in this case a for loop is not a function, so what happens is this. In ES5, regular JavaScript, this is key. You need to really grasp this. In JavaScript, unless you're using ES6 syntax, which is the arrow function, okay? The variables are scoped only to the block. So what the heck is a block? This is a block. Anything inside here is a block, right? Is this a block?
No.
Okay. So knowing what we know now, this here will always leak out to the global scope. Always, because you're actually declaring this in the global scope. Remember I said prototype goes where? Prototype goes up, global scope goes down. Remember that? So what happens is if you declare this here outside of a block, you're actually declaring it, it would be the same thing as declaring it outside. As a matter of fact, you know when you do stuff like this, you can do like I is equal to 0. Actually, let me see. I never actually tried doing this, but let's see if this will even run. Nope. Error.
Because it's not within the for.
You see this? It's no different than declaring it in the global scope. You see that? No different. So what would happen if all of a sudden you tried doing another for loop here, but you didn't re-specify? You just said index. Well, index is greater than, less than, let's say, 10. Like the same loop. Do you think this one will run?
I think it will.
Yeah?
We use the var index from the global scope.
Let's try it. Nope, didn't do anything. This is exactly why we have immediately invocable function expressions. Okay? This is another weird aspect of JavaScript. So in order to understand why ifs are around, you have to understand the scope chain and the global object. Let's take it one step further here, okay? Now, this isn't something that they showed you guys, right? Like, I'm not like just repeating something here, right? I'm guessing that's a no, is that a yes?
Yeah, this is something new.
New.
Okay, cool. Okay, so let's do this. So obviously this one doesn't run, right? This one doesn't run, so let's just delete it, right? So let's just comment it so that we know it was there, right? And let's just say will never run due to scope leak. Cool? Okay, so this is the deal now. What happens if I were to tell you?
Sorry, Dennis, can I ask something?
Yeah, what's up?
It will never run due to scope leak, is it because index is 10 at that point? At
Correct.
that point, index is 10.
Correct, exactly. Because the declaration, whether you do it here or you do it up here, It's the same thing. It will always be, because it actually belongs to the like, watch. What index is not defined, but cool. Okay, watch this. You see that? Which is what you're saying. But intuitively, why can't I access this? I can't access this one. I can only access this one, right? Because this was in the global scope. Now, let's just say I declare it inside, let's say I do this, right? Index is not defined. Get out of here. Why?
You have to put bar next to the index.
Oh yeah, my bad, good call. Same thing, right? So again, it's to your point, because this one will never run because the index is 10 at this point. Undefined, loops, 10, never runs, and then this drives the point that this is different scope, okay? Now, you see how this one didn't throw an error? It's just a block. It won't throw any error. Cool, anyways, so let's take this to the next level. I'm going to clear this, okay? And I'm going to call the window object, right? Why am I doing that? I'm just going to pick something that's global. Let's pick something here, device pixel ratio, whatever this is. You see this? I don't know why you would ever do this, but but this drives a different point. You see index? Look at this, guys. You see it? This is the window object, but index lives there. You see what I'm saying? Like inner width. Let's say length. Let's call it length. So, do you think this will run? What do you think this will do?
Wouldn't it give you the same thing?
Close. It will start at 0, and will give you the same thing. But, what did we actually do here? We actually did something a little funky. What we did is we overwrote the length property of the window. What happens if, for whatever reason, we chose something else? What happens if we chose like outer height? Let's say we were looping through something and we called it outer height. We were like looping through something, we called it outer height. Right? Starts off at 877 and it gives us the same result because we overrode it. Right? But what happens if our application now relies on outer height for whatever reason? Let's say you have some elements or you have some JavaScript that does some funky stuff when the page loads and it relies on a variable that's in the window or the global object in Node. If you declare the same variable name, it will literally override it and it will break your application or will do the weirdest shit you've ever seen. And then you'll be like, what the hell is going on? Right? Again, that's where the iffy comes into play. So, if you want to, for example, scope out, so where you're going to find this pattern the most notable, okay, is for security reasons. Okay? Like, for example, let's say when you load a page, other than actually other than actually trying to like shield your variables from the window, right? Or the global scope or whatever, right? Other than doing that, like let's say you have an application where you do like an Ajax call and then you save like user profile and I don't know, their name and their city and whatever, right? But you don't want people to access that. Like you don't want people going into the console log and being like user.name or something like that. You know what I'm trying to say? Like for security reasons, maybe you need to load a credit card, but I don't know why you would, but let's just say you're trying to load some kind of information about a user, but you don't want people to see that. You got to shield it from the rest of the application, or you got to shield the variables from being used by other applications, but you don't want to have that, but you want to have those immediately available. So what you do is you basically have to trick JavaScript into thinking that it is a function expression that's immediately invocable. I know that sounds kind of odd, but let's do another example here of it. Let's call this, I don't know, game. Let's just say we have a score, right? And the score is, I don't know, math. Let's just say a random, I don't know, this is going to be the dumbest game ever, but whatever. Let's just say it's a random number times 10. So, and let's only log the number if the score is, I don't know, greater or equal to 5. I don't know, whatever, just made some dumb game. So how would you get this working? You would do game invoke, right? Nothing crazy, right? And it's just true, right? False, true, 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 false. So it's like a random, I don't know, you just get random, right? So it's either true or false. Simple. Nothing crazy, right? I'm trying to think of a way that this is applicable. But what happens if maybe you didn't want people to know what the score was or something like that, right? What happens if you just wanted to display that right away? So a immediately invocable function, it starts off like this. You use parentheses, okay? And you shield it. And then you can do your function. Actually, no name. You're not allowed to have a name. And then you go var score equal to math random times 10. And I'm going to do the same thing. I'm going to do the score where it's equal to 5. Cool. Now, this doesn't actually do anything yet. And why is that? Can you guys think about why is that? This, if I do this, we'll get nothing in the console. Do you remember a function that returns a function? Do you remember this portion here? So essentially, ifs, you have to double invoke it. It's basically saying function expression and then call it. So this calls itself. You see how it's the same thing? But if I try to do, for example, score, it's undefined. I know this is a little bit weird. Again, we're doing all the weird stuff in JavaScript today. But this here is super, super, super common. You're going to run into this a lot, especially in Node. It's super popular in Node because you're going to use a lot of Node apps. They're going to use variables, and those variables will be commonly recycled, or they will modify other variables. Like, for example, like, is there a name property? you see name, right? Name is a very common property, right? Use like your object has a name, right? For example, so name is a common property. So if you want to have like a name come in and you want to use that name, well, you don't want to use the global variable. You want to use your own personal variable, and that's how you would extract it and bring it in. I know this is a little bit confusing, but what do you guys think about this so far?
It's good. I just don't quite understand how you extract the value from the shielded one.
Okay. It works the
Once
same.
you call it,
Sorry?
it self-calls itself, right?
Yes, as soon as it runs.
Oh, okay.
So because what happens is if you don't invoke it,
Nothing will happen.
nothing will happen. It's like nothing ever happened. It's just, so that's why it's an immediately invocable function expression. And it's a function expression because if it is not inside a block, if it's not a declaration, like this here is a declaration, right? If it is not a declaration, then JavaScript just thinks that this is the same thing as doing var equals or var num equals, I don't know, or just var num, initialization. Like, you know what I'm trying to say? So it treats these two as the same thing. Basically, it runs through the code in the execution stack. Okay? So during its execution context, it's going to say, okay, I'm going to grab all these variables, I'm going to hoist them to the top. It doesn't hoist function expressions. Sorry, it doesn't hoist declarations like this. Instead, it thinks this is just another variable, so it brings it up to the top. And as soon as it runs, it goes, okay, whoa, I got to run this right away. Boom. And then you get access to it right away. So you can have it anywhere else in the code. It will just run right away. Let's say, okay, let's do something else with it. So let's say.
Dennis.
Mm-hmm.
You don't do, if you're running 131 to, sorry, 231 to 230. Do you still need 224 to 228?
Nope. This actually doesn't do anything.
No, right? Okay.
Yeah. This actually. Oh, do you see? Now, if I take this away, this also doesn't do anything. So it's the same thing. That's why I kept it. These two, essentially, unless you do the double parentheses and call it at the end, it's the same thing as not calling it at all. The main difference is scope. And the fact, like, although normally you can't access this, normally you can't, like, it's true. Like, if you go like this, like intuitively you'd be like, oh, just write a function, right? And then you just run it, and then if you call score, it's obviously not going to work, right? That it's essentially the same thing, but the difference is that you don't have to call it anywhere. As soon as it runs, it automatically gives you access to that outside of the global scope. So it's a really common pattern. It's used widely, like it's used a lot. I learned it through seeing it in programs and not understanding what the hell was going on. So I learned it through practice.
So it's basically like the utility behind it, so no one can access what's inside of it. They can just see the result, but the function and whatever is inside it is shielded, right?
Yes, and they cannot figure out how to invoke it. So you don't need to call it anywhere.
Oh, okay.
So like, yeah, a lot of the times you're gonna shield data that you need to, when, like, let's say you need to load a resource. Let's say you have like a web page and it has like products, categories, and other parameters like pricing and some other stuff. So you need to load like a couple of models, right? So you have like a schema and it has a couple of tables and there's like relationships to each other, and that itself builds a product and all the data related to it. So you need to load a couple of resources before you actually display that to the customer, let's say, right? Now, if you need some of those parameters prior to making that resource call, like let's say I need to make an AJAX call to pull this from the database, but I need something else, but that something else is kind of private information that you don't want people just to access, that's where the iffy comes into play. Where you also don't want people to figure out that, hey, if I somehow run this function, I'm going to be able to access that information. You know what I'm saying? Cool. Ooh, what else did I have here? I had closures. Ooh. Closures are a tough one. Let's see. Okay. What? We kind of did a closure already. A closure is similar to a function returning a function, except it lets you access. So, I don't know, do you guys want to do closure?
Yeah.
I'd have to plow through it. I have a hard stop at 10. But, so, okay. Sorry?
I think it's too late, Dennis.
That's what I thought. Hey, listen, I have a hard stop at 10, so it's a little bit rough in 9 minutes. So how about this? Let's follow up on closure on the next Wednesday. We'll come back to it. Closures will tie everything together. Okay? So when you look at closures, you're going to see everything come together, except for iffies, obviously, but they do kind of relate. So I'll tell you verbally, and you can look into closures yourself now that you have this information, right? But essentially, a closure is an inner function that always has access to the variables and parameters of its outer function, even if that function has finished executing. So what the hell does that even mean? It means that if I run a function and it returns a function, if the first function finishes, I still have access to that parent function's variables, anything that's available in scope, even if that one is done. Which is like a really tough concept. Cool. So for the next like 4 or 5 minutes, do you have any like random questions? I don't know. Last time we did like professional questions. Anything like, I don't care what it is. Personal question, professional question, job question. You can ask me if I like cats. I don't care.
I have one last question regarding the EVs.
This one, yep.
Yeah. Are they sure there is a shielded from the DOM?
Sorry?
Like the EV functions are essentially shielded from the DOM, so no one can. They're not stored in the DOM.
It's not correct, but it's not only the DOM, but it's shielded from the global scope. We're just using this here is very visual. It's easy. It's like instantaneous to get a result, right? So in this case, yes, it is the DOM. But if you're running it, let's say from the console, right? Then it's shielded from the global scope of Node. Or let's say you're using it on a server. Like let's say you deploy your application is in production, right? When you run that iffy, the global scope of the application is not aware of anything inside the iffy. That's the true power of it.
And by just putting the two parentheses at the end, it's kind of like it's a way of making sure it will run, but there's no other way of accessing it in the global scope.
Exactly. As far as it's concerned, it doesn't exist. As a matter of fact, the reason why we don't The reason why it's not like name, right? You can't do this. Unexpected identifier. The reason why is because a function expression does not have a name. Like for example, you can't do var like fn name is equal to function name. This will not be cool because the name of the function is actually the variable name.
Yeah.
You know what I'm saying?
Yeah.
That's why this looks like this compared to this. Let's uncomment it so we can see it. That's why this and this look different. That's why you don't have nothing here because you can't do this. This will error out. So in order to do that, in order to make it an expression, it must be anonymous. It must be an anonymous function. So an iffy only accepts anonymous functions.
Oh, okay.
Right? That's why. Otherwise, it would be like, I don't know, name, call. You know what I'm saying? But that's unfortunately, that's not how it works. Now, ES6 has completely changed this. It does this under the hood. So an iffy is being called in ES6, but in ES6, if you just go like this, block scope, right? And you just go like, I don't know, log cool, like var cool is equal to cool, this works the same way as an iffy. ES6 iffy with a fat arrow. Block scope is the new. Oh, come on. I think this one. Come on. Block scope is a new iffy. Variable cannot be changed. Okay, if var variable name. Yep. Okay, so here's an iffy, right? And then ES6, same thing. And then you just go var cool equals, I don't know, cool, right? And then you go log cool. See?
So now they can have a name.
No, so it's still an expression. It's not any different. The difference is that you see here var score is whatever, right? It's no different. You're declaring a variable and then you're console logging the result, right? You're declaring a variable, you're console logging the result, right? So let's say we do the same thing. Let's not even change it, right? You know what I'm saying?
So one is available in the global scope and the other one isn't.
Yeah. No, they're both. They all like yeah. So this here, none of them are scoped, right? But the difference is you don't want to get into this because this is prone to breakage, and it's people can figure it out. If someone's smart, they can figure out how to run this. And if this contains like customer data or credit cards or something, you're in a whole world of trouble, right? Especially on a production application, right? So prior to ES6, this actually, as a matter of fact, for a long time, this was the only workaround. We're basically taking the weird parts of JavaScript and like faking a functionality to trick it to do something we want. In this case, is shield the scope of these particular items.
So they're not available in the global scope.
Exactly, so that you can use name, because name is an empty string, right? Right? So this is actually in the global scope. You see that? Because we're not using name yet, right? So as soon as I refresh, it'll say true, true. Where am I leaking? This one leaks. Weird. I did something wrong, but essentially that's the same idea. That's weird.
So technically it shouldn't show you.
Yeah, it shouldn't override.
It shouldn't show you what name it is. Yeah.
Yeah. Oh, it looks like we did name somewhere else. Weird. I don't know, my thing's turning weird. It actually is not supposed to do that. That's the whole point of it. See? Let's take an example. Yeah, see? Creates an output. Anyways, that's user error. That's definitely user error. Anyways, you're gonna see that in a lot of spots. Yeah, weird. You're going to find this in a lot of places, and it's very widely used. I suggest that you get used to it.
I think you know why. Because you're not calling it at the end.
Right here?
Yeah, maybe. I don't know.
No, I'll take a look. I'm probably doing something wrong here.
Try it now and see if it still shows the same. Type name again.
Yeah, it's weird. Because it's always the same value. There's no way, this is a random number. You know what I'm saying? I think what's happening here is that, remember when I did name the first time? I think it's cached. Let's find out. Open, and what?
You refresh the window.
Yeah, see? Look, no, it was a cached version. You see here, name?
Yeah.
I was like, that's not supposed to be happening. Anyways, so
So it's shielded, it's empty string.
yeah, because name is actually part of the window, right? Let's find name here. See, name is part of the window. So, okay. This, as an aside, you see what happened there to me? I had originally declared name somewhere up in the top. But because we've done so much work with the console, even if I refreshed it, it was still cached in memory because the window object is an object. Remember how we talked about mutating objects earlier on at the top? Anyways, so if you get a weird result in the console in the browser, just close it and refresh it, okay? Okay, so let's try this the ES6 way. So it's this little bad boy. This little ditty is the one doing it. Yeah, it's this little ditty.
This is being stored in the window name.
Exactly. So you can see here how this one is actually doesn't work. Sorry, no, sorry, West Boss. It no work, man. Is it West Boss? Yeah, it is. When did he put this? Oh, 2 years ago. We'll get West in the console, but if you stuff anymore, we'll using land and cons because we're going to be using this. Oh, okay. Yeah. Okay. That's my fault. Wow. Okay. Okay, so let me re-explain what happened there. Not only was it a cached version, My error, it was 100% user error. We're gonna do it again, okay? Do you guys understand what was happening?
It was getting stored in the memory. That variable.
Okay, so you know what was happening? This is gonna be another aside. Look what happens if I use var. var does not scope a variable to the block. If I use let or const, which is ES6, it will scope the variable to the block. This is another syntactical sugar. How does let or const work under the hood? See, blocks are not scoped. var t, right? And then variables oversharing and loops. This is exactly what we were talking about, remember? See how you get message goes in, right? Variables not scoped. And then let is the new var. So if you use let, anything inside the block, so the scope of a variable declared with let is just the enclosing block, not the whole enclosing function. They're still hoisting. If you use let everywhere, you'll never have this kind of bug. So basically what they're saying is this is a bug from the inherent use of JavaScript, which is basically saying that if I use var says that this now doesn't belong inside the curly braces. But if I use let, under the hood, basically they've used programming to kind of bind the values inside here to the curly braces. Does that make sense? Yes? No?
Yep, makes sense.
Yeah, because that var is like you can access it in the global scope, but let is within the local scope, like the block scope.
Yeah, I would say, listen, the best way I learned it, and I like to dumb things down for myself because I have way too much in my brain sometimes. Let and const scopes it to the curly braces. Var does not. That's it. There's nothing else to it. Var outside. So what var does, var says look outside of the curly braces and go to the nearest object. That's why when you use var like this dot name, that's why this works. See var person, right? So basically the best way to think of it is const and let, they create a little bubble. The bubble are the curly braces. So if you put let and const, it lives inside the curly braces. var breaks out of jail.
When you're doing constructors, you should always use var then?
Yeah, exactly. If you're doing objects, you must use, well, no, you can use const here. Constructor, you can use const because you're not going to reassign the constructor, right? But like if you're using, you cannot use, for example, what's the best way to put it? Like if you have something here, like the keyword this will break if you use let or const. Like remember we did like calculate age here. Remember we did, what the heck? Remember we did calculate age, right? So like calc age is equal to function. If I use arrow functions, for example, right? This will break. If I use the keyword this, it will break. Because the same issue. It uses the same idea of scoping. Anyways, that's enough. Cool. Cool. Awesome, guys. Any other questions while I'm still here? No? Okay, cool. Did you find this useful? Did you guys get anything out of this?
Very helpful. Thank you, Dennis.
Yeah, very good. Thank you.
Yes, very good. Thank you.
Awesome.
Okay, cool. I'm gonna try to do like a little poll, and let's think of some more. I'll try to get like gauge like, okay, what do you guys want to see next or whatever. I will still create. I think we would benefit a lot by going into deeper down the rabbit hole for some of this like really complex functionality stuff that will help you understand like React and more complex Node and maybe we can do design patterns too. Like I'll show you design patterns that are used in the real world. Like if you guys can nail down design patterns and this stuff here that we just did, I'm telling you right now, employability will skyrocket. Like literally it is huge because these skills and this knowledge is super marketable. Like this is the stuff that people are looking for because they don't really teach this too much and people just either are not aware of it or it's hard to get into it. Okay guys? So I'm gonna push this code. Let's see, ls cd, and I had another callback Ajax thing that we'll do later as well. Cool? Now, you guys ever use git diff?
No. What do they do?
It's exactly what you see. Shows the difference between the file on the last commit. Like let's say, right? Let's say we clear this. Let's say, okay, I showed Celia and Martin, but I don't use git status. I have aliases. Like see how I can just do gs. So anyways, I do git status always, and then I'll do git difference index, right? It'll tell me the last time I committed, this is the change I made. So I can just do I'll do git add index, right? And then I'll do git status again. You see how I can stage one at a time, and I'll go git commit, and I'll go modify the heading, right? And then I'll do git status, right? And I can just git push right now. You see how I'm pushing? But if I do git status again, you see how I still have unstaged changes?
Yeah.
Right? So I'm gonna do git difference now, and this is gonna show all the work that we did. Cool?
Cool.
So I use this a lot. Because what happens is I'll do like, and then I'll do clear, and then I'll always do git status all the time. I like git status, get used to it. Git status everything. Before I do anything on command line, git status. And then I'm gonna do git add the scripts, and then I do git commit went.
How do you create aliases?
I'll take that up next class. Gonna write it down. We'll do it. We do it through the bash profile.
Okay.
Create.
That's awesome. So it'll make it more efficient for every person.
But dude, I'm lazy, man. I hate typing commit and git status and all this other nonsense, man. It just drives me bonkers. Like I got so much shit to do. The last thing I need to do is like type out like little sentences to get one screen.
Yeah, that's true. So,
Someone's laughing at me. I'm telling you, lazy programmer is the best, man.
Is anyone keeping count how many times Dennis said shit tonight?
Leave it to Celia. Okay, I'm gonna get you back, Celia. You just wait. Oh, Jesus. Okay, I'm gonna push this code. You guys just go to the repo and download it, okay? Or clone it, whatever you gotta do. 15 and finished up to ifs. Cool? See how my master changed because I have no more stage changes? You see how the color changed too?
Yeah.
So.
Yeah, I'm looking forward to hearing about all those tools.
Yeah.
Yeah, so we'll do create aliases, we'll do bash tools, we'll do bash profiles. What else was it? You wanted the VS Code extensions and setup, right? And then continue on with closures. Deep dive into closures. What else did I have? And I have another code challenge, and then we're gonna do. Cool. Actually, yeah. The next Wednesday I have some exciting stuff. We'll do tooling. We'll do like environment setup, tooling, and best practices, and then we'll jump on, finish off what we were trying to do today. Which there's like 3 more units that I had prepared for us, which go like much deeper into this whole thing, and that includes the code challenge. And I'm gonna do some Ajax stuff, and we'll also build a library, and we'll see some new stuff. Sounds cool?
Perfect.
Sounds great.
Okay, guys. It's been a slice.
All right. Thanks a lot, Dennis.
Yeah.
Have a great night.
Yeah, you too, man. Have a good night. Have a good night, everybody.
Hey.
Ciao.